Hello guys, my name is Sebusiso, but you can also call me Coach Sbu. Welcome into the Maths Buddies channel. In today's video, I'm going to be showing you a method that you can use to look at a diagram, which is a second derivative, to help you find an equation of the original equation, which is the cubic function, right? So if you're a new viewer or a returning one, I'd like to welcome you into the video, and I'd like to please, if you have anything or any topic that you're struggling with, please be sure that you leave that into this video's comments so I can be able to generate a video for you. And lastly, don't forget to subscribe so that you won't miss when another video gets uploaded. So without further ado, I'm gonna go straight into today's video. Alright, so in this video we're given a diagram which is a second derivative, right? Diagram, and then as you can see here we're having an equation for f of x, and you can see that here we're dealing with a cubic function, right? So the first thing that I want to discuss is the diagram, right? So here we're given the diagram, and in this diagram we're told that this is a second derivative. So the first thing that you need to understand is you need to have a knowledge of what it means to have a second derivative, right? Now a second derivative means concavity, right? So this is what we use to determine whether concavity, so to determine whether the graph is concave up or concave down, right? Now when the graph is concave up, it means that the second derivative is greater than 0, and it is concave down, it is less than 0, but it is when it's at the point of inflection, it means the second derivative is equals to 0. Now this information, the reason why you need to have it is because now you need to understand that in this diagram, these second derivatives, they are the y values, right? So this means now here when you're looking at this, when it says second derivative is greater than 0, it means you're looking for the y values where this graph is above the x-axis, right? Now we can see that these are the x-axis, right? And then in the diagram I can see that here I have -1, but after -1 I can see this is where the graph is above. So this then tells me that this space where it is above, this is where the second derivative it is greater than 0. And also you can say this is where the graph is concave up. So the concavity, it becomes concave up when x is at the right of -1, right? Now what about this part here? Here, that is the x-intercept, right? Now we know in x-intercept, this is when what? The second derivative is equals to 0, right? Now this second derivative now in x as a y value. So this means now here at x is equals to 1, this is where at x is equals to 1, sorry, x is equals to -1. This is where we have a point of inflection, right? Now earlier we said here, this is where we have what? Concave up. So let me write it, concave up. And then finally, the last part that is here below this line here, we can see that here, the y values, which we call them second derivative, they are negative, less than 0. So this then means that x is less than -1, we're going to have a concave down. Right, so here, this thing, it really helps us to understand what is happening, because now we've analyzed it, then we can see that this graph, it is concave down when it's at the left of -1, and it has a point of inflection which has the concavity changes there, and then it is concave up at the right of x is equals to -1. All right, now we can go ahead now and read the instructions so that we can understand what the question is all about, right? So let's see. The questions reads as follow. All right, the graph of f double prime x, or the graph of the second derivative of f is equals to mx plus c, is sketched below, where f of x is px cubed plus 2x squared plus rx minus 27. All right, now the graph of f is decreasing where x is between t and 1. All right, now here we're given the graph of f of x, we see that, so let's say q8. So we're given that f of x, it is that px cubed plus 2x squared plus rx minus 27, and then we're told that the graph is decreasing where x is between t and 1. So what does that mean when we say graph is decreasing? All right, now here we're told that the graph is decreasing, so this means now that if it is decreasing, then it means the derivative, it is less than 0. So where does this thing happens? So it happens between 1 and t, right? Now this then means if we're saying the graph decreases between those two values, right? If it decreases between those two values, then this means according to the cubic function, the graph will increase at the left of this and also increase at the right of this, right? Now here we only told that f is decreasing, but you should also know that this also implies that the graph of f is increasing when x is at the left of t, right? And also it is increasing when f is at the right of 1, right? Now if you have an idea, or if you want to have a sketch of how this thing will look like, so you want to have something of this nature. So this part, this is where there is 1 here, and then this is where there is t there, which means the x coordinates of what? Of the turning point. So if you're saying at the left it's increasing, it will be in this nature, and then if you're saying at the right of 1 it is increasing also, it will be in that nature. So basically here, this is the idea that we have about our graph. Okay, let's go ahead now and read the question so that you can see what we have here. So here we've took out a lot of information, and just hope that it's going to be useful to us later. All right, 8.1. So 8.1 says let's determine the equation of f double prime x, right? Now f double prime x, we see that it is a straight line, so it's mx plus c, right? Now I can see in this sketch that I have 6 there as a y-intercept, so therefore it means c, I know in my straight line c is the y-intercept, right? Now therefore I'll say c is equal to 6, and then now to calculate the gradient, I can see that this point is a y-intercept, which means it's 0 is to 6, and then the other point there, it is an x-intercept, which is -1 is to 0. Therefore if I want to calculate my m, I'll say m is equals to okay, now let's just make an easy one. Let's just make an easy one. A quick one will be when we say f prime x first is equals to mx plus 6, which means we're first substituting the equation that we got, right, the value that we got for c, and then from here we can just use a point. So I'm going to use the -1 is to 0. So when I do that, it means here when I say 0 is equals to m into -1 plus 6, then 0 is going to be minus m plus 6, and therefore m is equals to 6, and therefore my second derivative, it is going to be 6x plus 6. Alright, what do we do here? Here basically we found our y-intercept, and then we use that to calculate the value for m, right? Because we used a different point here, right? So another way we could have done it, it would have been to calculate the gradient of m and then find it, and then after that we use a point to find the value for c. Alright, so now let's go ahead and look into the second question. Now the second question here, it says 8.2 says write down the x value of the point of inflection, right, of f. Now point of inflection, this is when the second derivative is 0, and here as you can see we've already mentioned that at x is equals to -1, that's where we have our point of inflection. So it means now x is going to be equals to -1. Now 8.3, they say use the graph of f double prime x to determine the values of x for which f is concave up, right? Now it says give a reason for your answer. Alright, so let's see. Now here we already mentioned that our second derivative, it is greater than 0 when x is at the right of -1, right? So here we then see that our value, we want to say concave up, means that the second derivative needs to be needs to be greater than 0. So therefore we see that when x is at the right of -1, our answer is going to be concave up. So the reason for this is because of what we just mentioned above. That is the reason. Alright, so let's go ahead and look into 8.4. Alright, now here, this is the part that I wanted to get into. Alright, so in this part, we want to show that P is 1, Q is 3, R is -9 by basically calculating or showing by all calculations, right? So the question here, it says show that P is 1, Q is 3, and R is equals to -9, right? And it says show all calculations. Now, how do we show all of this? So basically, this is what we do. First things first is we need to first have the equation of what? Of our second derivative, right? And then after that, we need to also have our equation for what? We're going to have our equation for the cubic function. -27. Alright, now here basically one of the easy way to find these unknowns, right, is to take this original equation and find the second derivative and then just equate the second derivative with this one, right? So that is going to be the first one here, right? So we're gonna find second derivative of f of x, right? Now how do we do that? So basically we're gonna take f of x, which is px cubed plus qx squared plus rx minus 27, and then from here we're gonna find the first derivative, which is gonna be 3px squared plus 2qx plus r, and then we're going to look for the second derivative, which is going to be 6px plus 2q, right? Then now after getting this, what we're going to do is we're going to take this 6px plus 2q and equate it with the original equation that we've already found for what? For our derivative, which is 6x plus 6, right? Now here what we're going to do is what we call an inspection. So an inspection is basically when you look at these two equations and say they can only be equal if this one 6px is equals to 6x, right? And when 2q is equals to 6. So that's the only way we can get these two things to be equal to each other, right? Now here we can see we're saying 6x is equals to 6, so this basically implies that 6p is going to be 6, right? And therefore when you divide by 6 both sides, we get p as 1, right? So having our p as 1, we can see that we've already found the value for p, and then on the other side we're going to divide by 2 both sides, and then we're going to get our value of q to be equals to 3, right? Now what do we have now? So here now in our equation for f of x, we have updated it to 1x cubed plus 3x squared plus rx minus 27, right? Now because of we have updated it to this, then this means now our first derivative, we're going to look at it as 3x squared plus 6x plus r, right? And of course our second derivative is going to be the one that we have now, right? So let me just write it here. Our second derivative now is going to be the one that we already have there. All right, now we need to find what? Now we need to find the value for r. So to find the value for r, we're going to focus mainly on what? On the derivative. Now if you remember, on the derivative we were told earlier that our f is decreasing, and then we explained that if it is decreasing, then it means its derivative is going to be less than 0, right? So that will be at the left, right? That will be between t and 1, right? And then we also said that this then implies that our derivative, it is increasing at x is less than t, and also it is increasing at x is equals to 1, right? Now this also means now that at t and at 1, our derivative, it is equals to 0, right? So now what we're then going to do is we're going to take this one here, right? We're going to take this equation here, and then we're going to say derivative is equals to 0. So this means here we're at the turning point. Then from there we're going to take our derivative plus r, and we're going to equate it with 0, and then we're going to use the point that we have from our information here. So at the moment we know that here the derivative is 0 at x is equals to 1. So now we're going to take that, so we're going to use the x is equals to 1, and then we're going to substitute it there, squared plus 6 1 plus r equals to 0. Then we're going to have 3 plus 6 plus r is equals to 0, so it's going to be 9 plus r, which is 0, and therefore r is going to be minus 9. And that is basically how we can find all our values. Now here, to update our equation, now we're going to have 1x cubed plus 3x squared, sorry, minus 9x and then we're going to say minus 27, and that is going to be our equation now for f of x. All right, now let's go ahead and look into another question, which is an 8.5 question. So 8.5 now says hence or otherwise determine the value of t. So to do that, we already know that this is our derivative, right? So basically what I'm going to do is I'm going to say derivative is equals to 3x squared plus 6x. Now I know what is my r, it is 9, right? Now what am I trying to do here? I'm trying to find the value for t. So if you remember, t was seen as a turning point or an x coordinate of the turning point of f. So it means now with my derivative I'm going to say that the derivative is equals to 0, and then I will say this is at the turning point. And then from here I'm going to take my 3x squared plus 6x minus 9 equals to 0, and I'm going to solve for x. So I'll divide by 3, divide by 3, divide by 3, and then x squared plus 2x minus 9, sorry, minus 3 is 0. And then when I factorize this, I'm going to have x, 1 and 3 plus and minus, then x is going to be 1 or x is going to be minus 3, right? Now earlier we did have x which was equals to 1, right? So this means now the other x, which is equals to 3, it is then the value for t, and therefore t is going to be equals to minus 3. All right, now let's look at the last question, which is 8.6. 8.6, it says for which values of x will f of x times f double prime x be greater or equal to 0. All right, now here here we want to find out the values of x for which this will be greater than 0. All right, now how are we going to do this? So basically, first of all, we're going to first need to write our f of x. So let's write our f of x. Now f of x is 1x cubed plus 3x squared minus 9x minus 27, and then our second derivative is going to be equals to 6x plus 6. All right, now there's two ways we can do this, right? Either number one, we can sketch the graph of f so that we can see where is it positive and where is it negative and all of that, right? And then we're gonna also use the second derivative to see where is it positive and negative and all of that, right? Or number two, we could first factorize, right? Factorize f of x, and then after factorizing f of x, write it using its factors, and then also do the same thing with f prime x, which is the second derivative of f. Factorize it, and then from there use what we call a sign table, right? Now, because of the purpose of this video, I'm going to do the one where we first factorize, which is using the synthetic division, and then find all of its factors, and then do the same thing with f double prime x, find its vectors, and then apply what we call a sign table. So I'm going to show you now in a bit how to do the sign table. So let's go ahead and do that. Now the first things first, what we need to do is when we finding vectors of f of x, what we do is we basically find a vector first by substituting the values into our equation, right? So that's basically how we find vector. So let's see there. So what I did was I'm writing the equation of f of x here, and then I'm gonna pick a number. So I'll say 1. So always start with 1 because I like it like that. And then I'm gonna put a number here. So the answer here is 32. So what I'm trying to do is I'm trying to find values, right? Or I'm trying to find a value that's gonna give me an answer which is 0, right? So 1 didn't work. So now I'm going to try to find 2. Let's see 2. What it gives us. It gives us 25. So it means the numbers are getting lower. So we're going to try 3. 3 there. And 3 here. See, I'm getting 0, right? So now here, basically what is happening is that I am seeing that at x is equal to 3, right? F of 3 becomes 0. So this means now x minus 3 is a vector. Then after this, I'm going to apply a synthetic division. So a synthetic division helps me to find other vectors. So a synthetic division, this is how you do it. First thing is you take the 3 that you had, you write it there, and then you draw a block like this, right? And then in this block, you're going to take the coefficients of these values. So it needs to be a coefficient for x cubed, x squared, x, and the constant. So here it is 1, 3, minus 9, and minus 27. Then after this, I'm going to drop this one, the first one in front, right? Now to apply the synthetic division, my aim here is to end up having 0 there. Alright, so how am I going to do this? So how you do it is you take this number, you multiply it there. So you're gonna say 3 times 1, which is 3, and then we're gonna add these, right, which is 3 plus 3, and then there's gonna be 6, and then after that we're gonna say 3 times 6 again. So 3 times 6 it is 18, right? So I'm getting an 18. So let me put an 18 there, and then I'm gonna add the two numbers. So minus 9 plus 18, it gives me 9, and then I'm going to say 3 times 9, which is going to be 27, and then minus 27 plus 27 becomes 0, right? Now here after this you can see I achieved my 0. So this then means now these numbers here, what I'm going to do is I'm going to write them according to the quadratic. So the quadratic formula is going to have the x squared is going to have 1x squared, and then the x1 is going to have a 6x, and then the constant is going to be 9, and I'm going to equate this with 0. Then from here I'm going to factorize this, right? So when I factorize this, what do I get? I get x and x, 3, so it's a plus and a plus, right? Then from here, after factorizing this, I'm going to take the factor that I've got there, which is the x minus 3, and I'm gonna put it in there, right? And then this is basically how we factorize f of x. Now what am I going to do with this? Therefore what I'm going to do with this is I'm going to go into my question. So the question was saying f of x times f prime x is greater or equal to 0. Now f of x, I'm going to write it according to its factors, right? And then I'm going to take second derivative of x is 6x plus 6, right? But when you factorize that, you can see it is 6 into x plus 1. So basically I'm going to do that. I'm going to say 6 into x plus 1 greater or equal to 0. Now this is one term, right? So this means here, if I want to get rid of this 6, I will just divide by 6 both sides, so that this 6 cancels out, and then now I'm only left with x minus 3, x plus 3, x plus 3, x plus 1 greater or equal to 0. Then now I'm gonna go and do what we call a sign table. So first let me write this. So what is a sign table? A sign table, it is a table that you use to basically understand the values of x and how this product behaves, right? So how we do it is, first of all, is we need to have our critical values. Now as you can see, the critical values here, it is x is equal to 3. So this x is equal to 3 is when you're solving that x minus 3. And then another one is going to be x is equals to minus 3, which came from that. So this came from that, this came from that. Then now another one will be x is equals to minus 3, which it came for that. And then another one will be x is equals to minus 1, which came from that. Alright, now what I'm going to do is this. We're going to take these values that we just got there, the critical values, then we're going to draw a table. So a table will be like this. Sorry, let me just draw that. Alright, now at the left of this table, we're going to list all these factors. So the first factor is x minus 3, and I'm going to draw a line like that. Then the second one is x plus 3, draw a line like that. Third one, it is x plus 3, draw a line like that. And then the last one, it is x plus 1, and then of course draw a line like that. Then after listing all those factors, I'll then write what's on my question, which is my question, it is f of x times f double prime x. Then now here at the top, I'm gonna list these critical values, starting with the small one and then ending with the big one. Now the idea here is that there must be space in between. For example, here you see I left a space here, I'm gonna leave a space there. So minus 3, minus 1, and then I'm gonna say 3. As you can see, space, space. All right, now what I'm going to do is this. I know that the x minus 3, when I was solving it, I got an x is equal to 3, right? So what I'm going to do is, at x is equal to 3, under this 3, because of I got it from x minus 3, I'm going to put a 0 there, right? And then after putting a 0 at the right, I'm going to put positive, and I'm going to put negative on the left, right, like that. Then I'm going to do the same thing with others also. X plus 3, when I was solving it, it gave me minus 3, so it means under minus 3 I'm going to put a 0, and then at the right I put a positive. Now the positive, they must align, right? This positive, they must be on top of each other. The negative, they see it's under this negative is at the top of the positive, and so on and so on. So here x plus 3, the x plus 3, I'm going to put a 0 there, then I'm going to put a positive like that, and then I'm going to put a negative on the right of the 0. Then x plus 1, it gave me a 0, it gave me a minus 1, so it means under minus 1 I'm going to put a 0, but then the left I'm going to do that, and then at the right put positive, but at the left put negative, right? Then now once I'm done with this, now I need to find the final product, right? So the final product will be basically the function itself, right? So the function itself, these terms, they were multiplying each other here, as you can see, right? So there was no factor that these factors were multiplying each other. There was no factor that divided another one. So basically what I'm going to do is I'm going to do the same thing now with the signs. If I want to generate the signs for this one, it means I'll multiply all these signs here. So here if I say negative times negative, I get a positive, right? Then that positive, if I multiply it with a negative, I get a negative, and that negative, and I multiply with a negative, my final answer becomes a positive. So it means I'm going to put a positive there, right? So once I put a positive there, what do I do then? So what I do after is I do the same thing for other signs also, right? So positive, as you can see, then negative times 0 becomes 0. When you multiply it by 0, it becomes 0, and when you multiply a 0 with negative, you get a 0, right? Then here negative times positive is a negative, times positive, which is a negative, times a negative, which becomes a positive, right? And then here negative times positive is a negative, times a positive, still a negative, times 0, then it becomes a 0, and then negative times positive is a negative, and times positive is a negative, and again times a positive is a negative. Then 0 times a positive is 0, times a positive is 0, times a positive is 0, and then positive, 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 of course, is a positive, right? Now, after doing this, I'm going to then go to my question. Now, finally, the question said f of x times f prime x greater or equals to 0. So what does this mean? So this implies that the product, the greater than 0 part, right? The greater than 0 part means that the product of f of x and its second derivative, it must be positive, and secondly, the product, it must be a 0, right? Now, when you look at the same table, basically it tells you where to look for, right? Now here you can see that using the sign table, I can see that I see positive here and there, right? And I see 0 there and there, right? And then because of that, what I'm going to do is I'm going to ask myself that where did it happen? Between which x values did this happen? So the positive here, it happened between -3 and -1. So therefore it means my first answer is going to be between -3 and -1. Alright, and then now where did another positive happen? It happened at the left of -3. So I will then say or this also happened at the left of -3, right? Then now where did the 0 happen? The zeros happened at -3, sorry, so I'm going to put an equal sign there, and also at -1, I'm going to put an equal sign there. And that is basically the answer that you're going to be getting on how we can solve the question that it is in 8.6. And that's how we do the cubic function. And that's all I got for you today. If you like the video, please make sure that you leave a comment. Tell me what you think about this video. I know that it took longer, but I just had to teach you this method that is called a sign table, which will help you to basically find anything about any question that has to do with for which values of x. And of course, if there was a sketch for f of x, it would have been much more quicker to do it, right? But then it's a 5 marks, which means we had to do one of the two, and the sign table was the one. And with that being said, I'm going to see you to the next one, where we'll be dealing with another method of a different topic. See you there. Cheers.